What if everything you think you know about time is completely wrong, not slightly off, not a minor misunderstanding, completely fundamental? Right now, as you watch this, you feel time moving forward, 1 second, then the next. It feels as natural as breathing, as undeniable as gravity. But here's the thing that keeps physicists awake at night. Some of the greatest scientific minds in human history, people who spent their entire lives studying the deepest laws of the universe, believe that time as you experience it may be an illusion, not a metaphor, not a philosophical idea, a literal illusion produced by your brain. And by the end of this video, the way you look at a clock and the way you look at your own life may never be the same. Every single day, time runs your life. It wakes you up in the morning. It tells you when to eat, when to work, when to sleep. You celebrate birthdays because of it. You mourn because of it. You feel its weight every time you look in the mirror and notice something new. Time is so woven into human existence that we almost never stop to ask the one question that changes everything. What actually is it? Not how we measure it. Not what a clock displays, but what time truly is at its core. Because here is the uncomfortable truth. You cannot touch time. You cannot smell it, taste it, or hold it in your hands. You cannot even see it directly. The only thing you ever actually witness is change. A child grows into an adult. A tree rises from a seed. The sun arcs across the sky and disappears. And because things change, we assume time must be passing. But what if we have it backwards? What if time does not cause change, and change is simply what we have mistaken for time? That question sounds almost too simple, but follow it far enough and it leads somewhere extraordinary. For most of human history, there were no clocks, no minutes, no seconds, no deadlines. Ancient people did not divide their days into neat, measured slices. They lived by the rhythm of the natural world. Sunrise meant wake, sunset meant rest. The migration of birds told them when winter was coming. For them, time was not a number. It was a feeling, a flow. Something lived, not measured. And then humanity made a decision that changed everything. We started measuring. Sundials became water clocks became mechanical gears became atomic oscillations so precise they lose less than 1 second over 30 million years. We got extraordinarily good at measuring time. But here is the question almost nobody thought to ask. Did we discover time, or did we invent a system to track something we never fully understood? The answer, it turns out, depends on who you ask, and some of the answers will disturb you. In 1905, a 26-year-old patent clerk in Switzerland published a paper that quietly shattered the foundation of physics. His name was Albert Einstein, and the idea he put forward was this: time is not the same for everyone. To anyone living in the 19th century, that statement would have seemed insane. A second is a second, a minute is a minute. Time ticks forward at the same rate whether you are a farmer in Kansas or a sailor in the middle of the Pacific. Except it does not. Einstein's special theory of relativity made a prediction so strange it took years for the scientific community to fully absorb it. The faster you move through space, the slower you move through time. Let that settle for a moment. Imagine two identical twins. One stays home on Earth. The other boards a spacecraft and travels at close to the speed of light for what feels like a few years. When the astronaut returns, something deeply unsettling has happened. The twin on Earth is decades older. The astronaut has barely aged. Neither experienced anything unusual. Neither felt time behave strangely, yet they lived completely different amounts of it. This is not a thought experiment anymore. Scientists have measured this effect directly using atomic clocks, one left on the ground, one flown aboard a high-speed aircraft. When they are brought back together and compared, they show different times. The difference is tiny, but it is real, and it is measurable. And here is where it stops being abstract. Your phone's GPS relies on a network of satellites orbiting Earth at nearly 14,000 kilometers per hour. Because of their speed and because of the weaker gravity at altitude, time passes slightly differently for those satellites than it does for you on the ground. If engineers did not account for that difference, every GPS on Earth would drift by several kilometers every single day. Every time your navigation app gets you home safely, it is because someone built Einstein's theory of relative time directly into the software. Time dilation is not a theory anymore. It is embedded in the technology in your pocket. But motion is only half the story. Gravity does something even more dramatic. The stronger the gravitational field around you, the slower time passes. This has been confirmed by placing atomic clocks at different altitudes. Even a few hundred meters makes a measurable difference. Now imagine the most extreme gravitational environment in the known universe, a black hole. The gravity near a black hole is so intense that not even light can escape it. And for an observer watching someone fall toward the event horizon, the point of no return, something almost impossible happens. The falling person appears to slow down. Their movements become sluggish. Their voice drops in pitch. Time, from the outside, appears to stretch like taffy. They seem to hang there, frozen at the edge of the abyss. From the falling person's perspective, nothing unusual. A normal heartbeat, normal thoughts, normal breath. Two people, the same moment, completely different experiences of time. This is called gravitational time dilation, and every experiment ever conducted has confirmed it. Which leads us to one of the most radical ideas in all of modern physics. What if time does not flow at all? What if past, present, and future all exist simultaneously, right now, and the only reason you experience them as a sequence is because of the way your consciousness moves through them? This is called the block universe theory, and it is not fringe science. It emerges directly from Einstein's equations. Several respected physicists, including Nobel laureates, have argued seriously for it. Think of it this way. Imagine a novel sitting on a shelf. Every page already exists. The beginning, the middle, the ending, all of it is already there, waiting. You do not create the story by reading it. You simply experience one page at a time. Some physicists believe reality works exactly like that. Every moment of your life, your first memory, this very second, every moment you have yet to live, may already exist in a fixed four-dimensional structure. You are not traveling through time. You are moving through a block of reality that was always already complete. If that is true, the implications are staggering. Free will, destiny, the meaning of loss and hope and anticipation. All of it looks different in a universe where the future already exists. And then there is one final twist, perhaps the strangest of all. Modern neuroscience has discovered that your brain does not actually process reality in real time. Everything you see, hear, and feel arrives in your conscious awareness a fraction of a second after it happens. Your brain assembles the information, smooths out the gaps, and presents you with a coherent experience it quietly labels the present. In other words, you are always living slightly in the past, not by years, not by minutes, by milliseconds. But it means this. The present moment you experience, this very instant, is something your brain is constructing. It is not a window onto reality. It is an edited version of reality, assembled and delivered just after the fact. So when you ask what time really is, you eventually arrive at this. We cannot touch it. We cannot see it directly. It moves at different rates depending on speed and gravity. It may not flow at all. And the only version of it you ever experience is one your brain builds for you, slightly delayed to make the chaos of reality feel continuous and manageable. No one has the complete answer. Not yet. The greatest physicists alive continue to debate it. Some believe time is one of the fundamental ingredients of the universe. Others believe it may emerge from something deeper, something we have not yet found the language to describe. And perhaps that is the most honest thing we can say. The more precisely we try to pin down what time is, the stranger and more elusive it becomes. So the next time you glance at a clock, pause for just a second. Ask yourself whether that second is really passing, or whether you are simply moving through a frame of something so vast and so strange that the human mind can only ever glimpse it sideways. The greatest mystery may not be whether time exists. The greatest mystery is why we were so certain we understood it.